Hello, this is Evie Derek-Lee, Systems Engineer at Cloudera. The purpose of this demo is to show how Cloudera can help businesses run their workloads on the cloud cost-effectively by providing them the choice of running transient or persistent clusters, the ability to dynamically scale those clusters up or down, and very importantly, the ability to seamlessly move their applications between cloud providers with minimal effort. This ensures no cloud infrastructure lock-in, which typically corresponds to more than 80% of the total cloud costs. In today's example, we will assume that our business needs to run certain ETL jobs on a daily basis. Our ETL jobs complete within a couple of hours, so we're going to use transient clusters to process the data and only pay for the few processing hours we need. We're going to use a simple Hive query to represent our ETL job. The input data will reside on S3, which is Amazon's object store. S3 provides the benefit of decoupling storage and compute, so the business can keep the data on S3, process it or query it with a variety of tools and various systems only when needed. The Cloudera stack is fully compatible with S3, so we will run our Hive queries directly against the S3 data and store the output back on S3. Cloudera also allows for direct replication of data from on-prem clusters to S3 through Cloudera Manager, so you can quickly and easily start taking advantage of the cloud. So the first thing we'll need to do is spin up a Hive cluster. To do this, our script reaches out to a Cloudera Director instance. Director basically is an orchestration tool for cloud clusters, and it can abstract for us the communication with the various cloud providers through its plugins for AWS, Azure, or Google Cloud Platform. As the picture shows, we will use the same job and submit it on all three providers. The output will be written to S3. As a final step, we'll show how the analyst group now can use their own Cloudera analytics cluster and connect their BI tools, such as Tableau in this example, to the now processed data on S3. Now let's start by taking a look at the input data. In my S3 bucket, I have a raw data folder, which contains some retail data. We see folders for stores, for sales, for customers. I also have my three public cloud accounts open here. This is my Amazon account, which we see has no instances running at the moment, my Google account, and my Microsoft account. In Azure, I do have an instance running, and this is my Cloudera Director instance. Cloudera Director can reside on-prem, it can reside on the cloud, on a VM, as long as it has connectivity to the cloud account. It can be anywhere that's convenient for you. Now, I will be using my local machine to submit my jobs, and I have here a number of files that I will be working with. I have a config file for each provider, the .conf file, which specifies the cluster characteristics I want. I have my ETL job, which is represented by the dispatch and the Hive job scripts, and three run scripts, which basically provide different parameters to the dispatch script. Let's take a quick look at the run script for AWS. Basically, I define which environment I want to use, AWS, my SSH connection, the cluster configuration, AWS conf, and the job I want to execute. If I look at the GCP run script instead, I just change the environment, in this case GCP, the SSH key I'm going to use, the configuration file is the GCP configuration, and I still use the exact same script for my job. So let's go ahead and execute our job on AWS. The script is now reaching out to the Director API, and it is requesting a new cluster using the configuration file that I provided. And we can see here the API call that it's doing. If I go to take a look at my Amazon account, soon enough we'll see the new instances starting. So now let's take a quick look at the Director web UI. I am going to log into my Director instance. And I notice now from the dashboard that I have one cluster starting on the AWS environment. If I hover over the progress bar, I can see exactly at what stage the cluster is at the moment. Now let's assume that the next day I will need to run the same job But this time the Amazon prices are really high because perhaps of a spike in demand from some of the largest Amazon customers. So I see that Google has cheaper prices, and so I choose to run my job on Google. And then the day after, perhaps Microsoft is cheaper, so I decided to run my job on Microsoft. So now we see exactly the same behavior, reaching out to the API and starting to bootstrap the cluster. If I go back to my directory instance and I look at my dashboard, I see that there are 3 clusters starting, 1 on each cloud environment. And again, I can see the stage at which they are. They're all at the starting stage. The Amazon one is already installing some packages and has moved on. And if I go back to my account, I see in Google I have a number of instances started. If I go to Microsoft, likewise, I have a number of instances being created. Now we're going to wait a few minutes for the job to execute, but in the meantime, let's take a quick look at the query that I'm running, as well as the configuration files that I've used. If I take a quick look at the query first of all, a couple of folders that I'm creating in the beginning, and then I'm creating some external tables, which, if you notice, point to my S3 raw data folder. And then at the end, I create an external table, yearly sales by brand, which will be saved in an output folder in my S3 bucket. So let's take a quick look at the configuration files. I'm going to start with my AWS configuration. This is basically a JSON object that defines what properties we want the cluster that will be used to have. And they're pretty similar between the different cloud providers that I'm using. In the beginning, we see that we define some characteristics about the provider. Type AWS, we need to provide certain parameters are unique to each cloud provider. For example, Amazon requires a region, a subnet, a security group, and so on. Then I have my SSH credentials. And after that, I have the templates of the instance I'm going to use. Basically, I have a master and a worker node template. I define what instance types I want to use and what AMI. And after that, everything is really identical in all configuration files. I have the Cloudera manager definition with just a few properties. I am using the 5.9 repository and 5.9 parcel for my Cloudera distribution, CDH. I have some HDFS parameters defined in order for HDFS to be able to communicate to my S3 bucket. And after that, one master node defined here with basically HDFS, Yarn, Hive, and 3 worker nodes with Yarn and HDFS on. If I'm going to take a quick look at the GCP configuration instead, you'll notice that they're almost identical. The initial part is obviously different. This time the type is Google. Google requires a JSON key, and that's pretty much it. The SSH credentials again. And then in the instance type definition, I still have a master and a worker template, but this time I'm using some different parameters that are defined by Google in this case. And then finally, as I mentioned earlier, the last piece, the Cloudera manager definition, 5.9 versions, and so on. And then my cluster definition, same HDFS parameters, same one master node, and 3 worker nodes. So let's go take a look at my jobs. I will go back to my director instance. And I notice now, actually, my AWS cluster just terminated and it disappeared. Basically what happens is that the cluster finished creating, it executed the job, saved the output, and it already terminated. And the other 2 are almost complete as well. If I go to my terminal and notice here the script I was running, I can see basically the log of the MapReduce job that executed, the time it took, and so on, and the cluster terminating in the end. So if I go and take a look now at my S3 folder, I'll go back to my bucket, I will refresh, and we have here the AWS output folder created for us. At this point, we have shown how using Cloudera, the fastest, easiest to manage and secure Hadoop platform, you can leverage the infrastructure of your choice on-prem or on the cloud, be it AWS, Azure, Google Cloud Platform, and execute the same exact code, the same jobs on all environments, so you can avoid infrastructure vendor lock-in. Now let's take our example one step further. Our retail transit workload executes at night. As we demonstrated, in the morning the analyst team comes into the office and wants to start querying the newly processed data. So let's show an example of what the analyst experience with Impala would be like. Based on the business needs, we can have an analytics cluster that runs 9 to 5, or perhaps a small persistent cluster that runs 24/7, but dynamically scales up or down during peak or off-peak hours, so that even offshore analysts can interact with the data. Cloudera Director provides the API to achieve that dynamic scaling. So for this purpose, we will spin up a small Impala cluster in this example, again on the cloud of our choice. To do that, we would use another cluster template, similar to what we did for the ETL jobs and the .conf files that we saw earlier. So we can automate the process through the Director API. For the sake of time, I have an Impala cluster already running. So I will go to my Cloudera manager and log in. I have a number of clusters being managed here. I'm going to my Impala, let's call it our analyst cluster. And I'm gonna first go to the Hue interface, which provides an easy SQL client in order to access Impala. So the first thing I want to do is create a connection between Impala and my S3 data. Now this can be something that will be automated in the script when you start your analyst cluster, but I want to show you how that would look like. I have a Cloud Demo database I'm using with no tables at the moment. So I'm going to create an external table, yearly sales by brand, and actually let's point it to the AWS output since we know it's already there. I'm going to execute this command, and soon enough I have a table created in Impala that points to my S3 data. I can do a quick select star in order to see that I can actually access my data. And I can see some output there. Wonderful. So the analysts, when they come in the morning, they may not want to use Hue. They have their own BI tools that they want to use. So let's assume that they're using Tableau. So they have in Tableau their dashboards created, and when they come in the morning, they want the dashboards to be updated with the new data. So I open my Tableau. We have a book here that is our dashboard of yearly sales. So the moment I open the dashboard, the connection was already established with Impala, which was a predefined connection. And now I can see the data that is stored on S3. So if I want to go to my Impala queries, and we can see here that there are certain queries that have run. Now, if I go and interact with this dashboard, let's say I want to filter on year 2000, and I see everything changing in my dashboard. If I actually go back to my queries, I will see that this query was executed right now, looking at the year 2000, and so I can actually have a true interactive experience using Impala as my analytical cluster running against data on S3. So to wrap up the demo, we have shown a full Cloudera architecture on the cloud, where we have leveraged Cloud's transiency for nightly ETL jobs, as well as Cloudera's interactive SQL high-performance capabilities for our analytics cluster, and we have served all our users. Note that this architecture works the same in all three public clouds, and my users have the exact same fast experience with all the security controls, of course, that Cloudera only can provide. Thank you very much for watching.